compost in the wintertime? Let's talk about wintertime composting. I'm in zone 5, Canada. We get to about minus 30 Celsius Fahrenheit, sometimes minus 40 on a couple days, February, March. So can you compost in the wintertime? When should you compost and how should you do it? Let's talk about it. So what is composting? Composting is basically the process of decay, life turning back into soil, the nutrient cycle turning over again. So what's really happening is carbons and nitrogens in organic material is being converted into humic, fulvic acids, and other organic compounds to return the nutrient back to the soil. So what do we need in order to compost? And how does that change in the wintertime? What we're really trying to do here is replicate what happens on the forest floor. So the forest floor has debris falling down, leaves, twigs, and it's combining with nitrogens in order to make forest soil. It's a little cold, but everything's frozen, but it'll make forest soil. When leaves fall from a tree, they're fairly heavy nitrogen source, and twigs, sticks will be a heavy carbon source. Here's an example of what I do with wood that I've used already. Is I'll just stack it as habitat for life. But what happens here as well is we have a carbon heavy source in the wood sitting on top of soil, and the carbon will break down slowly over time. The thing that's going to break down the carbon is mushrooms. The thing that's going to break down green leafy material is bacteria. Both of those things are alive, and both of those things perform respiration. So what do we need to compost? We just need to think about what does life need to survive. To survive, life needs air and water. So we need carbon, nitrogen, air, and water. And the reason why we need the air and water is because the things that are turning the compost over is the life that lives inside the compost pile, which is bacteria, protozoa, micro and macro arthropods, and fungi. Those all need water and air. So how does winter change that? Well, winter freezes water for one. So even though you have a compost pile that might have heat inside of it, the surface of the compost pile is exposed to cold temperatures, it's exposed to wind, and it's going to freeze. The action happens on the inside of the pile, but depending on how big your pile is, it's going to freeze solid. And as the ice freezes, so too slows microscopic life. I'm standing on top of my pond here that's frozen, and there's not a whole lot going on in terms of microscopic activity down inside the pond. The same thing with the frozen compost pile. So anyone who's made soup knows that there's a temperature range where bacterial activity is really, really high. Between about 40 Fahrenheit and about 150 to 180 Fahrenheit. Bacterial replication is very, very quick. So when you're making really hot soup that's boiling and bubbling over, and then you're going to cool it, you want to cool it through the 180 to 40 Fahrenheit range as fast as possible. And that's to keep the bacterial replication down in terms of just food health and safety. So in your compost pile, a good hot compost is going to be bacterial driven. Not that a cold compost is bad, it's just slower. And that'll be more fungally driven and driven by the macro life, the worms and the beetles and the flies and the larvae that's going to grow in a colder pile. In a hotter pile, that life doesn't want to exist in there, it's too hot. And the bacterial activity in the pile is going to be very, very fast. So when you go much above 150, 180, the bacterial action is going to slow down. It's too hot for it. And when you cool down below 40 Fahrenheit, the bacteria action is going to really slow down as well. So what that means is when it's -15, -20 Fahrenheit outside in a cold winter, the bacterial action is going to slow down almost to a crawl where it's basically stopped. So what that means is you're just not converting the organic material into humic and fulvic acid anymore. That action is slowed down completely. So does that mean that you can't compost anymore? Kind of. Jenny! So because the soil activity slows down so much and even stops when it freezes solid, that means that no matter if you want to compost or not, it's not happening in the wintertime. But you still have green scraps, kitchen scraps that you're generating. So even though you don't have to stop composting in terms of the human activity of composting, it does mean that you're not going to be composting in the wintertime, the bacterial activity of decomposing. So right now, we're out near my kid's garden. So I like to run I have decentralized composting. So I have compost bins right where organic waste is being generated. So we put a compost bin right near the garden. That way it's nice and easy, clean and prep out the beds at the end of the year, stick all, cut it up small, but stick all the garden scraps in the composting. What I like to do when I know the season's shutting down is I like to mix with the ratio and mess with the ratio a bit. I'll talk about that in a second, but I'll show you what my compost piles look like in the wintertime. Let's see. Whoa. Basically just piles of leaves. So what I do in the wintertime is I run my compost piles very, very, very brown. That acts like a brake, and it absorbs smells and it kind of keeps things nice and tidy for when spring comes. So let's talk about ratio and why I keep my ratio really brown in the wintertime. In the fall, I collect a few hundred of these guys, and I'll leave and save some near the compost piles. The rest I will shred and put on top of the gardens as a replacement layer of mulch. And I will also fill in food swales in the food forest, which I talk about in another video. I won't get too much into it, but I pick these up from other people, and what I look for is people who have a ton of bags that all look very full. If you see someone with 30 or 40 bags of leaves out on their properties that all look like they're full to the brim, the fullness is a good indicator of shredded leaves. So you can see here, dump some out to use in the composting. These leaves are all very well shredded. That's higher surface area and you can get more leaves in a bag. Full bags and many bags is a good indicator that the person has put just leaves in the bags. You're not going to find any nasty surprises like bags of dog poop, cigarette cartons, broken kids' toys, just other general refuse. You're not going to see that in someone who's got 30, 40 bags like that. So I'll save some of these. These are a great source of brown. So let's talk about ratio and why we want to have a very high brown ratio in the fall and the wintertime. So ratio discusses how many atoms, or by volume or by weight or by molecular level, like atoms, you have between nitrogen and carbon. Fulvic acid and humic acid have a very specific organic molecular formula that they follow when they assemble each other, when they assemble themselves and get created from the soil microbiology. What you typically want in compost is an atomic ratio of 40:1. That means 40 molecules of carbon. They make long carbon chains, these acids, and for every one atom of nitrogen. And oxygens will get mixed in there as well, because we're composting with oxygen, like I mentioned earlier, and then as well hydrogens will get mixed in there as well, because we are adding water to the pile as well. So all of these organic compounds are going to be combinations of carbon, nitrogen, hydrogen, oxygen, as well as other larger atoms, but in a smaller ratio. 40:1 by atomic weight is what you want in order for compost to go. But how are you going to measure 40 molecules of carbon? Are you going to measure 40 molecules, for every 1 molecule of nitrogen? It's not really going to happen. So what is typically easier is to follow a volumetric ratio. So let's talk about volumetric ratios. So volumetric ratio takes into account the actual compound that you're doing your composting with. Is it sawdust? Is it heartwood chips? Is it bark, twigs, leaves? What's your carbon source? Newspaper, all those other things, but newspaper, shredded cardboard. What's your nitrogen source? Coffee? Is it urine? Is it animal manure? All these things have very, very different ratios themselves, base ratios, molecularly, and densities of those, which then turns into a volumetric ratio of nitrogens and carbons. For example, sawdust has a very, very high ratio. It's almost all carbon. I don't remember exactly what the ratio is. It's somewhere around 150 to 250:1 carbon to nitrogen. On the other hand, manures, say cow manure, is almost perfectly at the proper ratio by itself. So depending on what you're mixing in your compost as the green source, and by green I mean nitrogen, not the color, or the brown source, and by brown I mean carbon, not the color. Depending on what you're mixing into your compost, you'll need a different volumetric ratio in order to properly compost. That's all nice and good, but no one's going to sit down there and calculate this stuff out. So what's actually better is get a general idea of what a proper ratio looks like and should be as a starter, and then look for signs of imbalance. That's the best way to go, because that's the empirical nature's telling you that you're out of whack, you're too heavy carbon, or you're too heavy nitrogen. So let's talk about that. I figured we'll walk and talk, and that way you're not just looking at my stupid face the whole time. I can kind of give you something to look at while I'm explaining stuff to you. And you can skip ahead to different parts of the video if you want to skip ahead. But where I'm living is Canada Zone 5. We have an abundance of carbon in the form of leaves, not just on my property, but everywhere around me. And because everybody rakes their leaves up and throws their fertility away, puts it in bags at the end of their driveway, it's an ample source of free fertility and free carbon for me. So in the fall, I get thousands of bags of leaves. This year I didn't do as much. I got a couple hundred, but typically I'll get thousands of bags of leaves. For the nitrogen source that I use, it's garden waste and kitchen scraps. So it's food that the kids don't eat. It's mostly leafy greens from the garden, and then also kitchen scraps. It's a lot of coffee. It's very easy to go around to coffee shops and get free coffee grinds. They're very, very good source of compost. And then I grow deep tap-rooted nutrient accumulators, which are kind of like weedy plants with large leaves with deep tap roots that drill up nutrients from deep down and put it in their leaves. And I grow a lot of that stuff so that I can use it in my compost. Stuff like comfrey, mullein, even dandelion. Dandelion will give you a lot of green material, but it's got a nice deep taproot. Those are all great compost activators. So in the fall, I'll harvest a lot of my comfrey, for example, and throw it into a compost pile as the green source. So in the early fall, my compost is very green heavy because I'm stocking it up. And then in the fall, I throw tons of shredded leaves in there, mix it up, and I drive my ratio way heavy on the brown side. And the reason why I do that is because I really want to absorb smells, and I want to set my pile up where I can just keep dumping kitchen scraps in it all winter long. And by the time I get to spring, I'm going to be roughly at the proper 40:1 by molecule ratio that I need for composting, or the roughly 4:1 volumetric ratio that I need based on the fact that I use leaves and kitchen scraps. The proper ratio for that combination, a little bit of leaves and kitchen scraps and coffee for the nitrogen, and for the browns, wood chips, and leaves. That ratio volumetrically, to be properly balanced, is about 4:1 heavy on the carbon side. 4 carbon buckets for every 1 bucket of nitrogen. So here are 2 more of my compost bins. These ones are a little more centrally located, closer to the house, so that I can get out here in 4 feet of snow. And I'll just pop the lid off and stick the kitchen scraps in these. My compost starts out in these black bins because it's mostly food and I don't want critters to get to it. When they've been in here, when this bin fills up, then I'll start filling this bin up. When that bin is full and I run out of space and I need another bin, this one goes and graduates onto the swale over there. And then now it's going to be an open pit compost, but it spends its first maybe month or so, as I generate enough waste, it'll spend its first month or so in these bins, locked away from life. Now, one thing about that is that these bins, they do have air holes for air infiltration into the sides, but because they're also exposed to the elements, this whole bin freezes in the winter time. So not only is the water freezing, which is not great for life, the pile is going to freeze solid, but also that really impacts how much air can get into the pile. If it's hitting just a wall of frozen material, you're not going to get air and oxygen deep inside of the pile. And also because it's frozen, I can't really turn it. So because I can't turn it, and because the water freezes, and it's so hard that I can't move the pile, freezes solid, I can't get air into it, I lose water and I lose air in the winter time, which means composting stops, even if the temperature wasn't cold enough for the replication of bacteria. The process is still going to stop because I can't rotate it, I can't turn it, and I can't get water into the pile. So you need nitrogen, carbon, water, and oxygen to decompose stuff, to compost, and I lose 2 of those in the winter time. So composting will stop in the winter time, but I can still put stuff in the pile. So composting, like a car, the carbon is the brake and the nitrogen is the gas, and the oxygen is the gas. So in the winter time, I'm applying a big brake and I'm holding my pile back. I'm also absorbing smells for when that spring thaw happens and everything starts melting. In case I'm a little too green, I want as much carbon in the pile as possible so it doesn't smell. As the summer comes, what I'll do is I will cut the grass. So I'll mow the lawn and I'll collect all the grass clippings. I'll take my compost and I'll spread it out on the swale back here. Let's go walk over there. I'll spread the compost out on the swale, and then I'll cut the grass and I'll add the grass onto the compost pile. Spreading and moving the compost is going to put a ton of oxygen in that pile, and then put it all on the swale here. So I'll put the compost on the swale, spread it out. It'll be very oxygen heavy. I'll cut the grass, I'll spread that out, and then I'll kind of fold it over and I'll build a pile, a nice, say, 5 foot wide by as tall as the angle of repose will let me put the pile, typically around 5 feet. A nice big pile, the bigger the better. The bigger you have more internal space for that soil microbiology to live in. The active zone of the compost is a larger volumetric space. They've done 3 by 3 foot square pile will decompose something like 3 times slower than a 5 by 5 square foot pile. So it's an exponential speed of growth when you make your pile bigger. So the bigger the internal area you can get your pile, and in the proper ratio, the grass is fuel, turning the pile, taking them from those black bins, putting them on the swale, and then putting nitrogen in, oxygen, give it a water, and that pile will just fire as soon as the temperatures get good. So that's how I start the pile. By the time spring hits, adding the green nitrogen all winter, I should be around the right ratio as long as I make my pile properly brown in the wintertime. So can you compost in the wintertime? Yeah, no, kinda, sorta. You can still put your organic scraps in the compost bin, it's just not gonna do anything. So go really brown in the fall, keep it brown all winter. Spring, lighter up with nitrogen, oxygen, maybe a little bit of water. Give it a nice turn as you build the pile and it'll go. But in the wintertime, not much is gonna happen. So hope you enjoyed the video, and I'll see you in the next one.